Subscribe our Nehra Classes YouTube channel to watch free live training sessions and to avail the membership facilities and additional perks, click the join button. Hello everyone, this is session number 22 of our ongoing RHCSA version 10 training. And in this session, we are going to talk about the password management in Linux. This session covers managing passwords for the local users. It explains three methods for setting password: passwd command, openssl password utility, and the crypt function. It also addresses password configuration and account management features like disabling, suspending, or locking accounts. So let's start the session with passwd command. The passwd command lets users change their passwords. So if I switch in the account of Vikas Nehra, this is a normal user account, and I try to change my own password, I can execute the passwd command. After the passwd command, I don't need to specify my username if I'm trying to change my own password. As soon as I press enter, it will prompt me for the current password. So I have to mention the current password of my account. Then it will prompt me again for the new password 2 times. Okay, but here it is saying the password is the same to the old one. Means every time whenever you want to change your password, you have to provide the new password or a different password. Okay, it will also throw an error if your password is weak. The tool will reject the password if it is weak. So in order to change the password, you can execute the passwd command, and your password should follow the rules of this password tool. Means the password should be complex, it should be more than 8 characters long, it should not be the same password that you are currently using. So those things you have to keep in your mind, and after that you can easily change your password by running the passwd command. In case if you forget the current password, you cannot change the password. So what you have to do, you have to ask the administrator or the root user to change the password for you. How can the root user or the admin user change the password? He can execute the passwd command for you. Means after the passwd command, the root user will mention the username of the user whose password he wants to change and press the enter key. Here it will not prompt for the current password. Here he can directly define the new password. So root user can bypass these checks and do not need to enter the old password. So with the help of the root user, you can easily reset or change your password. Root user can change the password for any user in your machine. Similarly, if the root user wants to change his own password, he can execute the passwd command like this. Okay. The binary file location of this passwd command is /usr/bin/passwd. If you will have a look at the permissions of this file, these are the permissions. We will talk about the permissions in the upcoming sessions. Here you will find a small s written over there in place of x. So what is the role of this character here? This will be covered when I will teach you permissions, but this is for the SUID bit. SUID bit is a special bit which can be applied on files or directories. This utility provides a feature to the user so that he can execute this file in the same way as the owner of this file is executing it. Means this passwd command will behave in the same way as it is being executed through the administrator account, even if the normal user is running this command. So once we execute the passwd command, this binary file gets executed and it stores the password in the encrypted format in the shadow file. Let me show you. There is a file inside the /etc directory with the name as shadow. This file is responsible for storing the encrypted passwords for the local user accounts. And this file is readable only by the root user. Look at this. There are no permissions present on this file. Only root user or the admin user can read the contents of this file. Let me show you the entire file with the help of cat command. Look at this. This line is for the root user and this last line is for the normal user Vikas Nehra. These are the service accounts in our machine. Okay. So the etc shadow file stores the encrypted passwords for the local user accounts. There are total 9 separate fields for each line in this file, which contains the password and its settings or the expiration settings for the user. Like the first column, or you can say it, the colon separated field, it is for the username. The next entry which is showing up here, it is for the encrypted password of the user. Similarly, there are total 9 entries present in this file for each and every user. We will talk about these entries. So the very first entry or the very first column in this file, it represents the username. The second one, it represents the encrypted password. The third entry in this file is for the last password change. The next one, this entry, it shows number of minimum days to change the password. Then the next entry, it shows password expiry date. Then the next entry, it shows the warning number of days before the password expiry. After that, the next entry, it shows inactivity lock. Then the next entry, it shows account expiry date, and the last entry shows the reserve field, which is currently empty. So let's talk about each and every entry in detail. The /etc shadow file in Linux is a secure place where encrypted user passwords and password policy settings are stored. Each line in this file corresponds to a user account and contains 9 colon separated fields. As I mentioned earlier, the first entry, the first colon separated field is for the username. It shows the login name of the user and it must match to the corresponding entry in etc passwd file. Let me show you. This entry here in the etc shadow file should match to the entry present in the etc passwd file. This second colon separated field, the second entry, this field contains hashed or the encrypted password. And there are some conditions. If this field is starting with a bang sign. Bang sign means this one, exclamation mark. That means your account is locked. If an asterisk is showing up there, it means account has no password. If there are double quotes, that means user has no password but allows passwordless login, which is not recommended. If it shows some special characters and numbers, that means encrypted password exists, and in the encrypted password, if the first few characters are starting with dollar, so the next character after this dollar sign, it represents the algorithm used for the encryption. The hash often begins with a special prefix indicating the algorithm. As you can see that we are able to see $y $. It means we are currently using yescrypt. It is a modern password hashing algorithm. So this password has been encrypted by using the yescrypt function. Yescrypt is a modern password hashing algorithm that is currently being used in RHEL 9 and RHEL 10. If we see $1 $, that represents MD5 algorithm. So there are different type of algorithms that are used for encrypting the password. If we are able to see $2a $, that represents blowfish algorithm. If we see $5 $, it represents SHA-256. If we see $6, it represents SHA-512. And if we see $y $, it represents yescrypt. Yescrypt is a function that is used for the password encryption. So in modern machines, in RHEL 9 and RHEL 10, we see this function to encrypt the password. So whenever we execute the passwd command, it will automatically encrypt the password and it will store the password in the shadow file. Okay. So the second entry here in this file, it is for the encrypted password. This one. This is the encrypted password for the Vikas Nehra user. Now, the third entry, this one. There is a number showing up here in the third field. The number of days since 1st June 1970. It represents the number of days since 1st Jan 1970 when the password was changed. So we can calculate the exact number of days on the basis of this number. So we can subtract from this number, from this date. So how many days have been passed after 1st January 1970? That will give us a date, and on the basis of that date we can know when the password was last changed. If we see number 0 in this place, so if we see 0, that means the password must be changed immediately after the next login. If we see 0 here in this place, that means the password must be changed immediately after the next login. And this option is very useful for enforcing password rotation policies. Okay. So this number which is showing up here, 20 202. That means 20,202. These are the number of days that have been gone after 1st January 1970. So if we add this number in 1st January 1970, we can get that date when the password was last changed. Okay. We can also list this information by using the chage command. So the last password was changed on 24th of April, means today. So total 20,202 days have gone from this date when the password was last changed. Okay. Now the next entry, fourth entry. This entry, this one, it shows minimum number of days before the password can be changed again. If 0 is showing up there, that means there are no minimum number of days. This prevents users from changing their passwords repeatedly to cycle back to an old one. Okay. Now the next entry, fifth entry. So the fifth entry here, it shows the maximum password age, means the maximum number of days a password remains valid. This entry, it shows maximum number of days a password remains valid. If we see this number there, 99,999, that means password will never expire. This is the maximum duration for the password, for a valid password in your machine. If I set this number as 100, that means you have to change your password after 100 days. Okay. Now the next one, this entry. So the sixth entry in this file, it shows the number of days before the password expiry that the user is warned. So this number tells the number of days before the password expiry that the user is warned. It helps the users to update their passwords in time to avoid account lockouts. Okay. 7 is showing up here. That means user will be warned 1 week in advance before the account expiry. Okay. The seventh entry, this one. This entry shows the number of days after password expiration that the account becomes inactive or disabled. Currently, this number is not set here. So this is a kind of grace period. If there is no number present in this location, that means there is no grace period. During this grace period, user cannot log in until they reset the password. Okay. So this is to provide a grace period to the user so that they can reset the password. If there is no number present, that means no grace period is there. Okay, now the 8th column in this file, it represents the absolute expiration date of the account. And again, it will be counted from 1st January 1970. When this date is reached, the account is completely disabled regardless of the password status. Okay. Currently, this number is not set here. So that means this account will never expire. And the last section, it is currently not in use. It is unused and it is reserved for the future use. The last entry here in this file. It is currently unused and it is reserved for the future use. Okay. Now let me show you the entry for the Vikas Nehra user. Wait a minute. So the first entry here, it represents the user Vikas Nehra. The second entry here, it represents the encrypted password for the Vikas Nehra user that has been encrypted using the yescrypt algorithm. Then the third entry, this entry shows the last password change date and the date is 24th of April. So on the basis of this number, we can calculate the exact date. The next entry, that means no minimum days are required to change the password. The next entry, it represents that the password will never expire. The next entry here, it tells the warning number of days before the password expiry. It is currently set to 7. After that, there is no inactivity log, there is no account expiry, and there is no last field in this file. Means it is not in use. The last entry is not in use. So this is all about the etc shadow file and its different sections. Okay. So how the password is encrypted and how it is stored in the etc shadow file. Let me show you. When we execute the passwd command, the password is encrypted using the crypt function. So let me add a user here in my machine. User is Nehra and let me set the password by running the passwd command. I'm defining the password as Red Hat. Okay, so I set the password for the Nehra user as Red Hat, but if I check the entry in the shadow file, I don't see Red Hat there. Why? Because the passwd command has used the crypt function to encrypt the password. That has converted the Red Hat string into this encrypted string, and that is stored in the etc shadow file. And here we are able to see $y$, which represents yescrypt function. Yescrypt is a modern password hashing algorithm that is more secure and resistant to GPU based cracking as compared to the older methods like SHA-256 or SHA-512. It is designed to be a drop-in replacement for crypt-based systems. It is memory hard, similar to algorithms like bcrypt, yescrypt, and argon2. There are different terms which are used in cryptography. Now the default, and in some newer Linux distributions including RHEL9, you will see this function there. Okay. So one method of encrypting the password is the passwd command that will automatically use some function to encrypt the password. There is one more method which can you use, that is openssl. The openssl passwd command generates encrypted passwords using a salt. How? Let me show you. So after openssl, we can mention passwd, and after that we can mention the password that we want to set. Suppose I want to set the password as Red Hat. So this command will generate the encrypted string against this Red Hat string. Look at this. And if you repeat the same command, it will generate a different encrypted string every time. Look at this. Every time it will generate a different encrypted password. Okay, and have a look at this. What is the current crypt function that is used to encrypt the password? If we will have a look at this, it is $1. It represents MD5. MD5 is a algorithm or is a hashing technique. Okay. So $1, $1, the first three characters here in this string, they represent the algorithm, the hashing technique. Okay. So as I mentioned earlier, every time for a same string, this utility generates a different encrypted password. In case if we want to use some other technique to encrypt the password, we can change the salt value. So what can we do? We can mention -salt here. Suppose I write here salt 42. So it will generate different technique. It will generate a different type of password. Again, look at this. If I write here $142, have a look at these first few characters in the encrypted password. They are different. So the encryption method can be changed by defining a different salt value. Now, we have learned how we can generate the encrypted passwords. Now, the question is, how can you use these encrypted passwords? How can you store these passwords in the etc shadow file? So while creating the user account, you can use openssl command utility to set the password. Suppose I want to add a user. So I'm going to execute the user add command, user add -m. Then -p I can use to define the password of the user at the same time while executing the user add command. And here I can execute openssl passwd, and suppose I want to set the password as my password, and I want to add the user having the username as Tarun. So I'm going to add a user with the username as Tarun, and at the same time I want to define the password for this user. So I can execute user add -p command, and after -p I can run openssl passwd and the password. Obviously I will enclose it in brackets, and I can execute this command. So this command will create the user and it will define the password as well. Let me show you. Tail -1 etc passwd. So we can see the entry for the Tarun user there in the passwd file. And if we check the entry in the shadow file, we can see the encrypted password there. But if you will have a look in the second field for the Tarun user, if you compare it with other users, you will find that this encryption technique is different. Why? Because this time we have used openssl utility, and this is starting with $1. That means it is MD5 hashing technique that has been used for this Tarun user. Okay, if I switch in the account of Vikas Nehra, and from there if I try to switch in the account of Tarun, so I have to provide the password for the Tarun user. Let me provide the password as my password, and I can switch in the account of the Tarun user. That means the encryption technique that we use to encrypt the password for the Tarun user is currently working properly. We are able to switch in the account of the Tarun user. So let's go back to the root user. So this is the second method of creating and storing the encrypted password. There is one more method that can you use. That is the homework for you. I have already provided the program in the document. You can create a file with the extension as .c, and you can use this program that can generate the encrypted passwords. This is the program. Okay, and you can compile this program and you can execute this program that will generate the encrypted passwords. It would require GCC packages. So you need to install GCC package in your machine, and after that you can execute this command. So this command will compile the program, and after that you can execute this file. I'm going to show you the steps. You have to execute this command. This will compile the program that you created earlier, and after that you can execute this function to generate the encrypted passwords. Okay, it will only work after compilation. So this is the third method of creating the encrypted passwords in Linux, but it is not important. The earlier two methods, the passwd command and the openssl command utility, those are sufficient for you. In case if you want to learn more, you can try this method. Otherwise, there is no need. Okay. Now let's proceed further. Okay. So as I mentioned earlier, in the etc shadow file, there are different sections present. So whenever we create an account, there are some settings which are by default showing up there. Means we did not set these numbers here. So from where machine is getting these values? So there is a file with the name as login.defs in the etc directory. This file is responsible for the settings like default password, account policies, expiration rules, password lengths. So all those settings are maintained with the help of this file. Okay. If you want to see the password aging related policies in this file, you can grab pass in etc login.defs file. You can have a look at this. It contains the settings for the maximum password days, minimum password days, minimum password length, password warning age, password change tries, password always warn. So these settings are already defined in this location, and from there these entries are copied in the etc shadow file. Okay. If you want to change the password aging or you want to make some modifications, either you can edit the shadow file, which is never recommended, or you can use the chage command. If you want to read the manual, you can go through the manual of chage command. Chage, change user password expiration information. So this command is very powerful command. With this, you can manage password expiration settings such as setting minimum, maximum password age, warning periods, etc. If you want to list the password aging information for any user, you can execute chage-l, and after that you can mention the username obviously. So it will show you this information. When the last password was changed for Vikas Nehra, it's 24th of April 2025. When the password will expire? Never. Password inactivity, when the password will be inactive? Never. When the account will expire? Never. Minimum number of days between password change? 0. Maximum number of days between password change? 99,999. Number of days of warning before password expires? 7. Okay, if I want to change these settings, I can execute the chase command. Chase and the username. So it will prompt me, and here I can mention the number accordingly. Suppose it is asking me to set the value for the minimum password age. Suppose I want to keep it as 5. Maximum password age, suppose 100. The last password change date, so I can define the date like this. Password expiration warning, 5 days. Password inactive, no, I don't need it, so I can skip it. Account expiration date, suppose I want that account should expire in 2029, 30th of March. So I can write here 03/20. Okay, now let's verify these settings. So we can again execute chase-l Vikas Nehra. Now look at this. The last password change date is 19th March 2025. Password expires on 27th of June 2025. Password inactive, never. Account expires on 19th March 2029. Minimum number of days between password change, 5. Maximum number of days, 100. And number of days of warning before password expires, 5. Now, let's verify these settings in etc shadow file. Look at this. Let me show you the entry for the Vikas Nehra. Let's grab Vikas Nehra in etc shadow file. Look at this. So we can clearly see that there are some modifications as compared to the previous entries. Look at this. All these values have been changed. This is how we can manage the expiration with the chase command. Now, the next point. It is again very important. How can you lock and unlock the passwords? To lock an account, prepend an exclamation mark to the password hash in etc shadow file. How can you lock the account? Let me show you. Let me switch in the account of Vikas Nehra. I can easily switch. Let me try to do SSH as well. SSH Vikas Nehra @localhost. Let me provide the password and I can easily do SSH in the account of Vikas Nehra. Okay. If I want to log the account of Vikas Nehra, I can open the etc shadow file in VI editor and I can go to that line where the Vikas Nehra is showing up. I'll go in this second colon separated entry and I can put a bang sign here. So this will log the account of the Vikas Nehra user. If I try to do SU, if I want to switch in the account of Vikas Nehra, I can easily switch. But if I try to do SSH, it will not allow me to do SSH. It will say permission denied. Means only the root user can switch in the account of this user, but this user cannot log in the machine. So Vikas Nehra is not allowed to log in the machine because his account is locked. Okay. How can we unlock the user? Simply remove the bang sign. Go to this line where Vikas Nehra is mentioned and remove the bang sign. After that, this user can log in into his account. Look at this. Okay. If you don't want to use the VI editor. This method is not good. You should never edit the shadow file, as I mentioned earlier. The second option is to use the usermod command. After usermod, you can use option -L to log the account. Now, let's verify the entry in the shadow file. So usermod -L did the same thing that we did with the help of the VI editor. Now, if I try to switch in the account of Vikas Nehra, I can easily switch, but Vikas Nehra is not allowed to log in the machine. I'm providing the correct password for the Vikas Nehra user, but the machine is not allowing us to log in into the machine. Now, how to unlock the user? Usermod -U command we can execute. This will unlock the user. This will remove the bank sign from the encrypted password. And now this user is allowed to log in. Okay. Okay. You can do the same thing with the passwd command as well. To lock the user, you can execute passwd -L and the username. This command will again lock the password for the user. And this user is not allowed to log in the machine now. Okay. To unlock the user, you can execute passwd -u and the username. Look at this. Now the bank sign is not there in the password section, and Vikas Nehra can log in the machine now. Look at this. So you can lock or unlock the user either by using the VI editor or by using the usermod command or by using the passwd command. Okay. There is one more method which can you use. You can edit the etc passwd file, not shadow file. These three previous methods were working on the shadow file, but this one you can try on the passwd file. Here in the password section, that means the second column, here you can put double bank sign. So this will do the same thing. Let me show you. Now we have put the bank sign there in the password section for the Vikas Nehra user. Now let's try to switch in the account of Vikas Nehra from the root user. We can switch in the account of Vikas Nehra from the root user, but if we try to do SSH, machine will not allow us because Vikas Nehra is not allowed to log in the machine. His account is locked. To unlock the account, again, edit the passwd file using VI editor and remove these bank signs from the password section. Now, Vikas Nehra is allowed to log in the machine. Okay. One more method which you can try. You can change the default login shell for the user. You can open the etc passwd file in VI editor, and instead of /bin/bash, you can write here no login. Look at this. Now let's try to switch in the account of Vikas Nehra. Vikas Nehra cannot use this account. So we are not able to switch into the account of Vikas Nehra. Now let's try to do SSH. Machine will not allow us to log in the machine because this time no shell is available to take the input from the user. No login. We have defined the shell as no login. That means this user is not allowed to log in. Okay. To allow the user, change the default login shell to bash or sh or ksh. If I switch in the account of Vikas Nehra now and I run chsh command, it will prompt me for the password. 1 minute. /pin/no login. Now define the new shell. Let me mention the new shell as /pin/no login. So this shell is not available. We cannot do it by using the csh. We have to manually edit the file. But if I change the shell to sh or some other shell, it will allow us. Now the default login shell for the Vikas Nehra has been changed and we can verify it by checking the contents of etc passwd. Look at this. The default login shell has been changed. So either we can change the default login shell by running the chsh command or by manually editing the file or by running the usermod command. With the help of usermod -s, we can change the shell as well. Look at this. Okay. So if we want that the user should not be able to log in, we can write here no login instead of bash. So I have shown you all the methods that can you use to lock or unlock the account or to what do we call it? To disallow the user to log in the machine. Okay. It is not a good idea to open the sensitive files like etc passwd or etc shadow in vi editor by running the vim command or vi command. Why? Because if you do not properly close these files, they can cause serious errors in your machine. So what is the best way if we want to edit the contents of these files? We can use vipw command. vipw can open the password file in vi editor. Now I'm going to show you some practice questions. The first question, you need to set the password for the Oliver user and the password should be secure99. In the second question, you need to set a password for Amelia and then log the Amelia account. After that, you need to verify logging with etc shadow file. In the third question, you need to disable the Oliver password using the passwd-d. Passwd-d is again a command that will remove the password section from the file. Let me show you. If I run grep Vikas Nehra etc shadow and after that I execute passwd-d Vikas Nehra. Look at this. This command will remove the encrypted password from the shadow file. Okay. So you need to disable the password for the Oliver and you need to verify it through the etc shadow file. Fourth question, what is the difference between locking a user and disabling a user password? So usermod -l is used for locking, and to disable the password we can use passwd -d that removes the password field. Try changing the Oliver password to Oliver, and which is similar to user Oliver. Try changing Oliver's password to Oliver. That means the Oliver user should have the password as Oliver. So you can execute the passwd command for that. Question number 6. Make sure Oliver has to change his password in 10 days. So you can execute the chage command. There are two methods. Either you can directly define the option after the chage command, or you can execute the chage command and you can manually set the parameters one by one. Okay. Next question. Apply the same rule system-wide for new users. So to make the modifications and to make these settings permanent for all the newly created users, you can define these settings in the login.defs file. As root, backup etc shadow and then copy Amelia's hash to Oliver. Can Oliver now log in the machine with the Amelia's password? You can try it. Try to copy the password, encrypted password of one user, and copy it in the password section of the other user and try to log in with the password of that user. Question number 9. Why use PIW instead of VI? vipw safely locks the password file to prevent concurrent editing, avoiding corruption. Question number 10. Use chsh-l to list available shells. Which user add option lets you to specify the home directory? How to check if Oliver password is locked? Okay, again, this is interesting. How can you check it? Either you can check the shadow file or you can execute the passwd-s command. Passwd-s and the username. If it says np means no password. If it says p, that means password is set. If it says l, that means the account is locked. Let me show you. Let's check for some other user. Look at this. P is showing up there. That means the password is set. Okay, if I log the account, suppose I execute usermod -l Nehra. That means the account is logged. Okay. So you can try these 12 questions at your own. You can check the solutions obviously. And if you need any help, you can post your comments in the WhatsApp group. So that's it from my side for this session. If you have any questions, you can ask me now.